This should be a familiar section to you as far as the concepts are concerned, but the vocabulary might be new. The word consistent basically means that the consistent systems have at least one solution. At least one solution. Independent systems, on the other hand, consist of unique, which means different, lines. If two lines are the same, and that means not unique, the equations are dependent. Now let's look at three cases here. In the first case, we have consistent and independent lines, or equations. This is where two lines cross and have one unique solution. Having a solution means that the system is consistent, and since the lines are unique, that means the system of equations is independent. In the second case here, we have inconsistent and independent lines. That would be basically where we have parallel lines. And when you have parallel lines, there is no solution. Therefore, it is inconsistent, having no solution, but the lines are independent, they're unique, they are different lines, not intersecting. In this third case, we're going to have two lines that actually lie on top of each other. They are the same lines. So they are lines which coincide with each other. And we don't say that there is an infinite number of, and we don't say all real numbers, we say infinitely many solutions. Now let's talk about the logic there. There are an infinite number of points which are on this line, so there are an infinite number of solutions. However, this point that I just drew in there is not on this line. It does not refer to everything. And we're not looking for just numbers, so all real numbers and infinite number of numbers doesn't work. We are looking for pairs of numbers, points, rather than numbers. So infinitely many solutions really is the wording that we want to use in this case. Okay, it seems like we have a rather easy problem here, and it is easy, but we want to look at this skill as an important skill. This is how we check our answers in this chapter. We want to know in this first case, if we substitute in 1 for x, have negative 11 times 1 plus 6 times 7/6, is that question mark equal to negative 4? In other words, is negative 11 plus 7 equal question mark to negative 4? You know that negative 4 is equal to negative 4, and the answer here is yes. However, we also need to check whether 1, 7/6 works in the second equation. Substituting this in, we have 7 times 1 plus 3 times 7/6, and we want to know, is that question mark equal to 23? We get 7 plus, now the 6 and the 3 are going to cancel, and we're going to get plus 7/6. Is that equal to 23? And the answer here is no. In order for this point to be a solution to the system, we needed yeses in both of these cases. So since it does not work in one of the two equations, the overall answer to part A is no. Now let's try the second thing with this next point. We substitute 2, 3 into the first equation. This gives us negative 11 times 2 plus 6 times 3. Is that question mark equal to negative 4? Well, This is negative 22 plus 18, and that is negative 4 on the left equals negative 4 on the right. So yes, it works in the first equation. We substitute this also into the second equation. 7 times 2 plus 3 times 3. Is this question mark equal to 23? That becomes 14 plus 9, which is 23, which is equal to 23. And this time the point works in both equations, and so yes, 2, 3 is a solution to the system.